So this is the lesson that I will teach on Friday. What is a derivative of a function? Well, we know a whole lot. It is the instantaneous rate of change. Instantaneous rate of change. It is the slope of the secant line. Slope of the tangent line. But it also actually has two definitions. One is it's the limit as h approaches 0 of f of x plus h minus f of x all over h. So essentially this is change in y over change in x as change in x approaches 0. The other is the limit as x approaches some value a of f of x minus f of a over x minus a. And we're just going to practice using those definitions today and see what happens. So for question number 1, we're given the function e to the x. And we're looking for the derivative, the slope of the tangent line at x is equal to 1. So I'm going to use the definition that involves the h. So this is the limit as h approaches 0. We're going to have our function at x plus h minus our function all over h. Now we are looking for this at x is equal to 1. So I'm going to plug 1 in for x. And we can see what we can do with this. Well, one thing I know that we can do is we can rewrite e to the 1 plus h as e to the first times e to the h minus e to the first. And then what I can do is factor out an e to the first. So that's going to leave me with e to the h minus 1 all over h. And then, in fact, I'm kind of stuck. There's nothing I can do. It's not as though I can cancel out the h in here because the truth is that my understanding of limit is not sufficient yet. So as far as I can go, we're stuck here. So that's it. Let's do the same thing for sine of x and see how far we can get. So it looks as though we're looking for the slope of the tangent line at pi over 4. So I'm going to look for the limit as h approaches 0 of sine of x plus h minus sine of x all over h. And again, x here is pi over 4. So I'm going to plug that in. And I might be very clever. I might remember the function for the sine of the sum of some angles. That's going to be the sine of pi over 4 cosine of h plus the cosine of pi over 4, the sine of h, and then we're going to take out the sine of pi over 4. So we're just using what we remember from trig. And then I could plug in sine of pi over 4 I know is 1 over root 2. Cosine h, cosine is 1 over root 2. Sine h, sine of pi over 4 is 1 over root 2. So all of this is fine. It's looking very promising. I'm going to pull out 1 over root 2, and that leaves me with cosine h minus sine h minus 1 over h. I'm looking for the limit as h approaches 0, and unfortunately at this point, if I plug in h is equal to 0, I'm still going to end up with 0 over 0. This will give me 1 minus 0 minus 1, so 0 over 0, indeterminate form, so I'm kind of stuck again. So the point is, even though I can use the definition, I don't have the algebraic tools to come up with some number. For question 3, let's try again. Our function is ln x. We're looking for the slope of the tangent line at x is equal to 1. We're going to take the limit as h approaches 0 of ln 1 plus h minus ln 1 all over h. ln 1 is familiar to us. We know that that is 0. So we just end up with the limit as h approaches 0, ln 1 plus h over h. And once again, I'm stuck. Algebraically, there is nothing I can do. Let's try the next one, p of x. So we're going to take the limit as h approaches 0. Let's see, x is 2, so I'm going to have 2 plus h. My function is x squared, so I'm going to square that thing, minus 2 squared all over h. Let's do some algebra. And this works out, 4 plus 4h plus h squared minus 4 all over h. The 4's cancel out. I can factor an h out of each term. And that is just going to leave me with 4. So that works out nicely. I'm going to try the same thing with x is equal to negative 2. So the limit as h approaches 0, we're going to have negative 2 plus h squared minus negative 2 squared all over h. So limit as h approaches 0, let's work this out. We're going to have 4 minus 4h plus h squared minus 4 all over h. Those 4's cancel out. Let's factor 4 out of each, h out of each term. And once again, that troublesome factor in the bottom cancels out, and now I am free to plug in h is equal to 0, so my slope is negative 4. Let's just talk about how reasonable that seems. That definitely should be a negative slope. That definitely should be a positive slope. Notice they're just opposite signs, which seems to make sense to me with the symmetry of this parabola. Okay, to finish it up, let's look at inverse tan. So we're looking for the limit as h approaches 0, inverse tan of, let's see, this is at 1, so 1 plus h minus inverse tan of 1 all over h. I know inverse tan of 1 is pi over 4, but there's nothing I can do with inverse tan of 1 plus h. I don't know any expansion formulas, so I cannot possibly plug in h is equal to 0. I know this is going to give me, if h is 0, this is going to give me pi over 4 minus pi over 4, so 0 on the top, 0 on the bottom. So this is as far as we can go. For question 7, I'm looking for the slope at x is equal to 2. So I'm going to take the limit as h approaches 0. I'm going to have 2 plus h cubed minus 2 cubed over h. I can work this out. So this is the limit as h approaches 0. 2 plus h cubed, I know is going to be 2 cubed. So 8 plus 2 times 2 squared times h. 2 times 2 times h squared. I'm using the binomial theorem here. Minus 8 all over h. Our 8's cancel out, and I'm just left with the limit as h approaches 0. Let's see, that's going to give us 4, so that's 8h plus 4h squared plus h cubed all over h. Whoops, I knew something was wrong. These are 3's. 3, 3, so that's 12h plus 6h squared. In any case, what I can do is cancel out the h's, plug in h is equal to 0, and that will give me a 12. So some of these work, some of them don't work. What we're looking for question 8 is just to practice this. So if I look at 8a, what I know is that somebody here is taking the derivative. Probably didn't get very far, and the notation I'm going to use is somebody is taking the derivative of sine x at x is equal to pi over 4. Over here, somebody is taking the derivative of, well, the function must be 4 to the x, right? This is f of a plus h minus f of a, right? So my a value, or my a plus h, is right over there, so a must be 2. So this is 4 to the a, so my function is 4 to the x, and somebody is looking at this at x is equal to 2. For c, my function, somebody is taking the derivative of, well, it's going to be something squared at x is equal to 4. For d, this is the derivative of, my function is going to be 2 to the x at x is equal to 3. Function here is somebody's taking the derivative of e to the x at x is equal to 1. And lastly, we're taking the derivative of square root of x at x is equal to 1.